Right. So firstly 3a, so you have z inverse square root z minus 3 all over z inverse square root z minus 5. Okay, well here these are exactly the same, so they can cancel. Because I have a square root over top and bottom, I can make that one large square root if I like. And then finally, because I'm dividing, what do I do to the powers? Subtract. So minus 3 minus 5? 2. And then square root and square? Cancel. So you're just left with... Yeah.
So if you have, I don't know what you call it, when there is power on the square root.
Yeah.
Okay, like how...
Like cube root or something.
Yeah.
Do you mean the on the left or on the right?
On the left.
Yeah, so like for example this here.
Let's say, yeah, B. B has both of them. One on the outside and one on the inside.
All that does is it just means this power 1 over 3. So you just replace that with that.
And if you have it on, okay.
And then if it was also on the outside as well, then it just goes on the outside here. And these get multiplied, yeah. 2e. Really? Okay, yes. Can I go to a new page? Yep, okay, 2e, so. Right, fourth root, 81, fourth root, 243, 3, fourth root 3. Right, well, firstly, I think 83 goes into 81, doesn't it? So what's that? 3 into 8 twice 6, 27, is it?
Yeah.
So this will be fourth root 27. 27 is 3 cubed, isn't it? So if you want, I can change this 81 over 3 into 27, and 27 is 3 cubed. Now, this here is fourth root and fourth root, so that's fourth root 243 over 3. But 243 over 3, 3 goes into that, doesn't it? So let's see, that'd be 1, 4, 3, 6, 9, 12, 4, what is it, 1, oh, what am I doing? Yeah, 3 doesn't go into 2. Sorry, 81. Now, 81 is 3 power 4, isn't it? 3 times 3 times 3 times 3 is 81, right? So this equals fourth root 3 cubed, fourth root 3 power 4. Well, that's great because what happens here? That cancels that. So you're left with fourth root 3 cubed.
3 times 3 and 3.
Oh, and times 3, sorry, thank you. So 3 cubed times 3? 3 to the power of 4, and then what happens here?
3 cancel.
Cancel again. And then the answer is 3, I hope. Yep.
If you just kept it as a square root, you use it correct?
No. This is the only answer, 3. 2, 3, 4, 5, 6. We're missing a few people, all right, aren't we? One of the Ahmeds, Joseph.
Joseph is in the immigration.
Oh, he's in immigration, okay. Well then, does that make Muna in immigration as well? Oh, there you are, there, sorry. Didn't see you up the front. Well then, the other person, what's her name?
Read.
Huh? No, the other person that started at the same time as Muna. What's her name? Lujane? Is she in immigration too? And then what about Reem? Yes, I wasn't in my class as well, I've never seen her. Oh no, this isn't for you. It looks like I was pointing to you, sorry. Reem. Where's Reem? Do you know? And, you mean Ali, maybe? Okay, anyways, I'll do, what did you say, Faisal? 3W, okay. Next one now. 3W. 3 log 2, 4 plus 9 log 8, 2 minus 2 log 2, 8. On the next page, 57, yeah? Yeah. Now, sorry, if you can't see, this here is an 8. Shh. Now, this is the question, we need to simplify it. So firstly, what do you think? Well, I'm going to change this here. I can easily see what log 2,4 is. What's log 2,4? 2. No problems there. This isn't so good because it's more convenient to have the bigger number on the top. Although you could work it out. To make it easier, I'm going to flip these around. So then here is log 2,8 minus 2. And then what's log 2,8 here? 2 to what power makes 8? 3. And then likewise, 2 to what power makes 8? 3, isn't it? Yes? 9 divided by 3? So that's 6 plus 3 minus 6, so the answer is 3. One sec. Who said, excuse me? Yes? You know your calculator works then, but for the exam, they'd want the steps. I'm sorry to tell you this. Of course, feel free to check that your answer's right in the exam with your calculator, but the answer by itself wouldn't do. I'll tell you the only exception maybe. Can you listen please? This is important for the exam. If the question was calculate this, then they would definitely want the steps. Okay? But suppose you're doing a bigger question, and it just so happened in the bigger question you have to calculate this as part of the process. You know what I mean? Then it would probably be okay to just put that in the calculator. Second class. I knew there was someone else I forgot. So I'll say that again. If the question was only saying calculate this, then you would definitely need to show your workings. But if the question was something bigger, where this was a step in the process, then your calculator would probably be okay. Yeah?
Didn't you say, like in the previous class, that we're supposed to solve the, like 3 log 2,4 and minus 2 log 3,8? Like solve the same issues together first?
I actually never said that, but okay, I'll go with that. You can, but what I'm saying is, you can put these together if you want by using rules. You know what I'm saying? But, hey, no. Because these numbers are small, I can see the answer straight away in my head. But suppose this was something like 4,000 and this was here 80 or something, then you would want to try and put them together to make them smaller. But it's certainly, if you can see the answer straight away, like how it is here, then just put the number in straight away. And like here. Although this one here in the middle is not so clear.
Can you do one more time?
Okay. Which one? I'll do another one from page 57. Please pick out one that you would like to see.
Question 5.
5.
Told us we don't really.
Yeah. No, 5's okay.
Yeah,
3O looks like it's a little bit more difficult than this one. Okay, so 3O now. 2 log 5 125 plus 6 log 125 25 minus 3 log 525. Actually, I just realized what you were talking about the last time, and that I think you're saying put these together because they're both log 2. But what I think what you're talking about is if this was log 2.4 and this was log 2.4. That's what it wasn't what you're talking about. Okay, then I don't know what you were talking about. I don't think I said this.
No, because what you just said is log 2.4 is when we join them together.
Again?
You just said when we have log 2.4.
Log 2.4.
Is it
you just
like,
put one of them, right?
is
No,
it-
no,
is
please.
this time when we join them together? Because I remember you said something when we were supposed to join them together, or it's just something.
Yeah, we did an example like
Yeah,
that.
we did
That
it.
three
Sure it was
more-
me. You weren't in another maths class. I don't remember this. Yeah, no, there's only two ways I can think of joining them together. The first one is if this is log 2.4 and this is log 2.4, you could put them together. 3 log 2.4 minus 2 log 2.4, what would that be? 1 log 2.4, right? Or the second way is, because they're both base 2, you can use the division rule. Although the slight problem here is you have numbers in the front. So you'll have to get rid of those numbers first. How could you get rid of these numbers? Well, you could bring them up to powers, couldn't you? And then once they're up in powers now, then you could put these together. Log 2 something minus log 2 something, then it's log 2, and you divide.
When you do that,
Huh?
multiply the power or
When bring the power up? You see, the thing with this is, there's not one way to the answer. Like, I could have done that and still got the right answer. Like, there's not, you have to go this way to get to the answer, you know? So if you wanted to, you could have brought the powers up. But the reason I didn't do that is because I would have made this bigger, and that's not helping me. So I suppose if this was a fraction, maybe I'd want to bring it up. You know, for example, if this was a half, if I bring it up here, it'd be 4 power a half. And what's 4 power a half? 2, yeah, because it's square root 2. So it really depends on the numbers, you know. But don't worry about it. It's not like there's only one way to the answer. If you did that instead, you'd still get the right answer. Maybe for, yeah, maybe for fun, we'll do it with the powers. So here, this would be log 5, and then that goes up there to make a square. So can you do 125 squared, please? 125 squared. 15625. And then here I can bring it up as well. Actually, but before I do that here, you see how the same problem, this is smaller than the base? Then I'll do the switch again. 6 over log 25, 125. And then minus, so here, bring the 3 up to the 25.
15625.
Oh, I'm out of space. Let me write again.
Now it's
minus log 5, 625. Oh no, it's cube, sorry. What is it?
Isn't it 1.5, like, it's 125 squared equals...
No, this is 25, isn't it?
Oh, yeah.
Yeah, 25 cubed. Yeah, what's 25 cubed? 15625. Now what's great here, you can think about it two ways. This is the same as this, so you can cancel them. Or if I wanted to use rules of logs, when I subtract, what do? Divide. So what's 15625 divided by 15625? 1. And what's log 1? 0. But that's the same as if I cancelled them, you know, so it didn't really matter. And then here, what's log 25125? I think that's, I don't know actually. I was going to say 3, but it's not 3, because 25 cubed is not 125. So, I'll need to simplify this a little bit.
3? 6 over 3?
Wait, slow down. I need to simplify this a little bit. What's 25? What's 25 as a, what's 25 as a power, if you were to make 5 squared, okay? So look carefully, please. 5 squared. And then in blue, what's 125 written as a power? 5 cubed. So think carefully. How do I go from a 5 squared to a 5 cubed? Now think about it.
You multiply by 3 over 2.
Oh, you know what? I'll make your lives easier. Okay. What can I do with the tree here? What can I do with the tree? Take it down, right? So now maybe this is a little bit easier. I can swap them back. Well, what's 6 over 3? Whoa. 6 over 3? 2. And then if I swap them back, this would be log 5 squared. So that's very clear now. 5 to what power makes 5 squared? 2, yeah. Wasn't a trick. 2 times 2? And 4. Okay. Yes?
First step. Why you didn't put 3? First step. Yeah, why you didn't just put 3? Multiply 2. Because 5.
Where? Here?
No, first step there.
Here?
Yeah, here. Why you just put 3 multiply 2?
3 multiplied 2? Here?
No, it means like say to replace 125 by 5 cubed and then like say 3 times 2.
But you told me you wanted me to do it with the powers. That's why. Yes, I would normally have written this as 5 cubed, but at the start you told me you wanted this brought up to the power.
I mean 5 over power 3 and then you multiply 3 over 2.
Okay, that's fine also. Yeah, if you want. Whatever you like, I don't care. It's okay. This isn't the way I would normally do it though, but you're right. If you want, you could have changed this to 5 cubed and then brought the 2 up to make 5 power 6. If you wanted to. Yes? Okay. Oh no, we still need a minute. Well, I'll take the attendance while you're doing that. Can you just hand me a pen, please? Okay. Ahmed Al-Baharna. That's the other one. He's the one not here. Okay. Fumi. Okay. Faisal, yes. Theme, yes. Precious. Oh, there you are. Mishari. Oh, there. Sarah. There. Hind. Reem. No. Marana. Shiraz. Amjad. Abanoob. Hamad. Not Hamad. Mohammed. Yes. Brendan. Joseph. No. Ali. No. Hassan. Yes. Sadiq. Not here. Sayun. Ahmed Kurdi. Yes, you. Hadid. Yes. Ahmed B. Okay. There you go. Okay, now we're going to page 59. So, for this exercise, there are not any new rules. We're just going to use our rules of powers that we know to solve equations with powers. So I'll do one of each type. So I'll do 1A. 2x minus 1 equals 8 minus x minus 3. So the first problem here is that you have a 2 and an 8, and they should really be the same. But that's not too bad because it's easy to change 8 into a 2 with a power. What's 8 as 2 with a power?
2 cubed.
Yeah, 8 is 2 cubed. So that's the first thing I should do. Okay. Now, because I have two powers here, I multiply them. So I get 2 minus 3x minus 9. Is that okay? And really the next step isn't too much of a leap. If I have 2 to a power, and that's exactly equal to 2 to another power, well, the powers have to be the same. They can't be different. It doesn't make sense. You couldn't say 2 squared equals 2 cubed. So in other words, I know that the powers here must be the same. 2 to a power equals 2 to a power. The powers must be the same. Yeah? Which part? Yeah, they're equal, yeah. X minus 1 equals minus 3x minus 9. Okay. Take the minus 3x to the left. That makes it 4x. Take the minus 1 to the right. 1 minus 9. Minus 8. And then just a quick division here. So x equals minus 2. You write this down, Ahmed? Yeah. Okay. I'll do 2a now. It's really going to be the same idea, just a little bit more complicated. 3 power 5x minus 6 equals square root 81 2x plus 6. Alright. Well, first thing I should try and do something about the square root. So as a power, what could I do with the square root? Yeah. So, what happens to the powers here? Yeah, well, they get multiplied by a half, don't they? So what's 2x multiply a half? 1x, yeah. And then 6 multiply a half. 3. Now, like before, I don't like the 81 here, so what can I do about the 81? That's 3, 4, 3, 9, 27. Is it 3 power 4? Yeah. Yeah, it is. 3 power 4. Minus? Oh, sorry, thank you. Okay, let me go down a little bit. Okay, so here I get 3, 5x minus 6 equals 3, 4x plus 12. So just like before, 5x minus 6 equals 4x plus 12. So I get x equals 18. Yeah. Did it start with the question? Yep, okay. So there you go, x is 18, no problem. Last type, 3a. So far, question 1 and 2, the equations only make one answer, but we'll see in a moment that in number 3, you'll actually get 2 answers, which should give you a little hint of what happens here. Quadratic, yeah. Right, just like before, first problem is that you have a 2x and a 4x, so we should change which one?
The 4.
The 4. So what's 4? 2 squared x minus, yeah, no, that's fine. Minus 6, 2x plus 8 equals 0. But for what I want to do to make it extra clear, rather than writing 2x like this, instead I'll write it like this. Now, of course, that's exactly the same because 2 times x is the same as x times 2. But the reason I did it like this is because you can very clearly see, not cancel, but if you look closely, here you have something, here you have the same something, here you have something squared, here you have the something by itself, and here you have a constant. So if you were to, in your head, replace the 2x with some other letter, like for example, big X, this would be like x squared minus 6x plus 8. Now you don't need to write that down, but I'm just making it clear. The form that I have in the red and the blue here is called a quadratic, right? The only difference is, instead of having x as the variable, what's the variable here? No, 2 power x. Now if you want, you can factorize it, or you can use your minus b formula, the quadratic formula. I don't mind which. So this is, if you want, you can just take out the calculator really quick and type in mode 53. And the coefficients would be 1, minus 6, and plus 8. So first answer is? 4. And second answer? 2. So rather than saying x equals, here we say 2 power x equals and 2 power x equals. Okay, not quite finished yet. This is like what we've seen before. I should change 4. What's 4 as a power? 2 Power 2. And here, what's 2 with a power? 2 power 1. So again, by comparing the powers, you get your answer at the end. X equals 2 or x equals 1. And now it's finished.